Find that. You should recognize this drawing as something that you can do a normal CDF on. Now we want upper bound, lower bound, comma, upper bound, upper bound, upper bound. And again, I don't have to get z-scores for my lower bound and upper bound. If I give it my actual values here of negative 0.78, comma, positive 0.78, my hypothesized mean, and my standard deviation, I don't have to do all that extra stuff of finding z-scores. Okay, so tell me what my probability of my type 2 error is.
Is the probability of your type 1 error alpha?
Yes, the probability of the type 1 is always alpha. 0.29. Oh, and we agree, something. That's good. Okay, so my probability of my type 2 error is 29%. I got a higher probability of making a type 2 error here. All right, new thing. Power. The power of my significance test is the complement of the probability of the type 2 error. So it's 1 minus the probability of the type 2. And in this case, that's 1 minus 0.29, which is 0.71. Good. And so I say the power of this significance test is 71%. To detect an alternative mean of 1, because that power is going to change depending upon what my alternative was. Okay. 71 ain't good enough. Yes.
What do you mean, like, to detect the...
So this mu sub a equals 1 was something that we had to set in order to find the probability of the type 2 error. The type 1 error, we didn't have to grab any other numbers out. We could just do it strictly from the alpha. Now we got to detect if the true mean was actually 1, how powerful is my test to reject the null hypothesis correctly?
Wait, so the mu sub a is sort of like alpha?
The mu sub a is something that we may have some historical knowledge about. There may be something in my field of studies that always gets set. It has to be this far away from the mean. There are ways of calculating it. We won't decide what the mu sub a is. We'll just calculate our power based on them, our type 2 and power. Yes, that will always be given to you. Okay, we need a power of about 0.8. So let's try to increase our power. No, it's whatever you're given. Okay, so I want to increase power, so let's try changing alpha. So let's keep our sample size at 25 and change our alpha to 0.01. Okay, 25, sorry. Our alpha at 0.01. Okay, so let me go back to my original hypothesis. My mean is 0. I'm going to reject my null hypothesis if I'm out here in these tails. To find that critical value where I reject, let me do an inverse normal from, use 0.005, I'll do the one on the left, with my mean of 0 and my standard deviation of 0.4, and my critical value is... No. I got negative 1.03. Anybody else getting that? Check me out.
So everything's the same except you change the alpha.
I changed the alpha. Negative 1.03 or 1.3? Okay, cool. So I'm going to reject if my sample mean is below negative 1.03 or above 1.03, so I'm going to fail to reject. Yes.
Shouldn't your 0.4 should be a different number?
No, my standard deviation is going to stay the same, and my sample size has stayed the same.
So the negative 1.03 is S bar?
It's my critical X bar.
Oh my god.
Okay? Okay. So if I'm less than negative 1.03, I reject the null hypothesis. If I'm greater than 1.03, I reject the null hypothesis. I fail to reject if I'm in the rest of that space. So yes.
Sorry, what's the difference between critical X bar and regular X bar?
An X bar would be just whatever sample mean that I got. A critical X bar gives me a place on the x-axis where I'm going to reject my null hypothesis if any sample is less than that or greater than that. So that 1.03 is just a place on the x-axis for me. And if I get a mean bigger than that, say 1.33, I will reject my null hypothesis. It's just a place marker on that distribution. Okay. All right. So my probability of my type 2 is going to be the probability that my sample means are between negative 1.03 and positive 1.03. For that, I'm going to do a normal CDF from negative 1.03 to positive 1.03, giving it the mean and the standard deviation. Now, what is the probability of my type 2 error? Point what? I didn't get 0.97. 0.99. I didn't get 0.99. So let's.
I got
I do.
0.99.
It's a normal CDF from negative 1.03, 1.03, comma 0, comma 0.4. Okay. Sorry. How about 0.99? Do you have something quick?
Yeah, I'm
Okay.
also fascinated too.
Okay.
My kids don't mind this.
Now, power is the complement of the probability of the type 1 error. So my power is 1 minus 0.99. My power is 0.01. It's not very powerful. Remember we needed power to be greater than 0.8? Oh, so this is terrible. So if I make my alpha really small, I don't have a high probability of a type 1 error. But why did we make alpha small? We're trying to improve our. Ask again.
Why do you need it to be greater than 0.8?
So it's kind of standard. It's kind of industry standards. Usually, like the power of your test to be greater than 0.8.
So is that just like
Okay.
you should know that?
Yes. Yes. So my alpha was 0.01. My power is 0.01. It's too low. All I did to make that too low was I changed that alpha to something really small. Do you have something quick? Because it's kind of a long
No,
lecture.
that's fine. Should we move this over here and put a review in anything?
Yeah, but it's about getting in enough days. Yeah.
Wait, are the alpha and the power normally the same, or
No, I didn't think they were going to be. I didn't mean for that to confuse you. So sorry that they turned out to be almost the same. I must have run my numbers wrong last time. Okay. So that did not work to increase power. That decreased